David Can here with another question from your Hayes and Harris Math SL textbook. This is Chapter 6b, Question 3, Part A. It says, for the following quadratic equation, determine the discriminant in simplest form and draw a sign diagram for it. Hence, find the value for m, for which the equation has a repeated root, two distinct real roots, and no real roots. All right, so we have a quadratic equation here, except that we have an unknown m. If we want to find the discriminant, it's going to be b squared minus 4ac. A is the coefficient in front of the x squared term, b is the coefficient in front of the x term, and c is the coefficient of the constant term, or it's just the constant term. So a is equal to 1, b is equal to 4, and c is equal to our unknown m. So let's make that substitution in, and we'll get that the discriminant is equal to 4 squared, take 4 times 1 times m. 4 squared is 16, and 4 times 1 times m is 4m. That's our discriminant. Now taking a look, we can see that the critical value here is when m is 4. Because if m is 4, we get 4 times 4, that's 16, and 16 times take 16 is 0. So the discriminant is equal to 0 when m is equal to 4. The discriminant is greater than 0 when m is less than 4. So if m isn't quite 4, if it's less than 4, then we have 16 take a number less than 16, and we wind up with a positive number for the discriminant. And finally, the discriminant is less than 0 when m is greater than 4. So if m is greater than 4, we have a number bigger than 16. 16 take a number bigger than 16 is a negative number. So the sign diagram for the discriminant is just going to look like this. It's centered around the number 4. When m is greater than 4, the discriminant is negative. And when m is less than 4, the discriminant is positive. What that means is that everything in this region, we have no real solutions. Everything in this region, we have 2 real solutions. And right here at 4, we have a repeated root, 1 real solution. So 1 real solution, that's our repeated root. 2 distinct real roots. And no real solutions for parts 1, 2, and 3.